right. Welcome, everybody. Welcome to another IAEI News Live. My name is Thomas Dimitrovich, and we are going to talk about, we're going to take a look at Chapter 4, which is Equipment for General Use. We're going to hit Article 409 for Industrial Control Panels. So, industrial control panels play a critical role in our power distribution systems, especially, I would argue, especially in the commercial and industrial environments. I would say that's you're going to see those solutions, those types of solutions applied in those applications more often than in a dwelling unit, so to speak. But that doesn't mean that you don't have Article 409 type of equipment in dwelling unit applications. So Freddie B., Michael Hofkin, David Engelhart, Laurel, and Omaha. Welcome to, and great to see you in our session today. All right, so I wanted to, first let's take a look at, Yummy Fudge is in the house. Good morning, sir. Good morning, good morning, good morning. So let's take a look at Article 4. So 409, Article 409 deals with industrial control panels intended to operate 1,000 volts or less. So low voltage type of equipment, relatively low voltage. And 508A is our reference standard for that equipment. And I would argue 508A, let's take a look at 508A since it is the topic of discussion. Excuse me. I'm going to make sure I have the latest edition of that, which the last edition was April 24th of 2018. That is the latest edition of UL 508A. That's your standard for industrial control panels. So UL 508A is your standard for, whoa. That's weird. There we go. Standard for industrial control panels. That's the reference. Now, what I'm going to do is I want to look real quickly. I want to look at the scope of 508A because here's the thing. If we're referencing products that are listed to this standard for Article 409, I think it's going to be important for us to understand what's 409's scope, what UL 508A's scope is. So if I look at the scope in the standard, it says the requirements cover industrial control panels intended for general industrial use operating from a voltage of 1,000 volts or less. This equipment is intended for installation in ordinary locations in accordance with the NEC and where an ambient temperature is between 41 degrees Fahrenheit and 104 degrees Fahrenheit, unless the equipment is marked with an ambient temperature rating. So if it's not marked with an ambient temperature rating, we know our operating range is between 41 degrees Fahrenheit and 104 degrees Fahrenheit for that application. So the scope of the standard, hey, Joseph Violi. Forgive me. The scope of the standard aligns very well with the scope of Article 409. Now, so in the introduction to the standard in Section 1 scope, they also give you a little bit more description. The equipment consists of assemblies of 2 or more power circuit components, such as motor controllers, overload relays. So if I had a box with a terminal strip in it, that would not be a 50, and a terminal strip only, it would not be a 508A type of an assembly because it needs 2 or more power circuit components. And they give you some examples of that. And they tell you it has to be contained within an enclosure or mounted to a subpanel. The industrial control panel does not include the evaluation of the controlled equipment. So if you have an industrial control panel, you're not addressing what that industrial control panel is controlling and the functionality of that, unless it is a part of the overall assembly. It could very well be that I make an industrial control panel that is designed to be used with, say, a specific motor, and I have diagrams that demonstrate how they're set up as a system. That then would be a part of the 508A evaluation, but I would have to call that out because I could have something that's mounted remotely. So anything that, here's another important piece of this. From an industrial control panel perspective, the UL 508A evaluation and review is not looking at the functionality of the controlled devices. You got to think about things separately. If I have an industrial control panel and it does X, Y, and Z, I'm going to list it to 508A. If I attach that industrial control panel to a piece of equipment, say an appliance, say an HVAC system, for example. If I have an HVAC system and I have an industrial control panel that's controlling the HVAC system, the operation of the HVAC system will be listed separately. Right? I would say it's almost similar. Michael Hofkin, you can correct me if you think I'm wrong. Anybody else out there can. Please feel free. If I'm wrong, slap me, right? Make it happen. If I list, say, a panel board, I can have a panel board that is listed, but the circuit breakers that go into that panel board are listed to a separate standard. But then I would list the panel board with those circuit breakers, and I would identify those circuit breakers that could be installed in that panel board. But that's a completely different standard. I don't cover the panel board with the breaker under the UL 489 for circuit breakers. UL 489 is circuit breakers, UL 67 is panel boards. I can put a UL 489 device in a panel board and I would test that assembly, that UL 67 assembly panel board with those other components. And I might have other components in that equipment as well. But each of those components are listed to their own standards and evaluated independently, and then the assembly evaluates that. I would say it's very, very similar to an industrial control panel itself. There are many components. I can put circuit breakers inside of an industrial control panel, and UL 508A will look at all of those components as they're assembled in an enclosure to perform whatever it is the function that that control panel may need to perform, say elevator control panel. So I would list that to 508A. I list each of those individual components to their standards. And Michael, correct me again, but if I have an assembly, I could have a recognized component that is a part of that assembly to support the functionality of the assembly, and it has to be used as part of that assembly if it's a recognized component. So now you get into the whole aspect of I have a listed solution with possibly listed components inside, or UL recognized components within that assembly. Supplemental protection, supplementary protectors. You have that in the National Electrical Code. I can put that inside of an industrial control panel to provide a function, but it's not protecting the branch circuit, right? So in those cases, you may have listed products or UL recognized products. And Michael says, panel board can be listed for use with certain breakers or components. Absolutely. All right, so fire pump controllers are not covered under UL 508A. That's under UL 218. So if you're looking at fire pump controllers, that industrial control panel for a fire pump is not listed and evaluated as part of UL 508A. That's evaluated as part of UL 218. And they say that specifically in UL 508A. Scroll down without flipping to the next page. Equipment intended for use in hazardous locations, as defined in Chapter 5 of the NEC, are part of UL 1203. So if I'm using it in a hazardous location, I'm not a 508A, I'm a UL 1203 product. If I am looking at industrial control panels that incorporate intrinsic safety barriers, again in hazardous locations, are a UL 698A, which is the standard for industrial control panels related to hazardous classified locations. So that's another. Michael Hofkin says, correct, a recognized component can be used in a listed product. A recognized component is identified with a U and a backwards R, the backwards R is a recognized component. Let's take a look. I'm in the UL standard 508A right now, still in the scope to understand what standards are covered by what. Industrial control panels, I already said about that. Motor control centers. Now you would think, okay, motor control centers are the epitome of controllers. So why wouldn't that be a 508A assembly? Because it's a UL 845 assembly, which specifically deals with motor control centers. All right. So it's important to understand the product that you're looking at to know where in the National Electrical Code you need to go. If you're looking at a control panel, for example, on a fire pump controller, you're not in a UL 508A environment, you're in UL 218. And if it's a UL 218 device, you're not in 409. You're back in Chapter 6, fire pump controllers. That's, I think, 695. Is that 695? I'm testing I'm outside of the boundaries of my comfort. And it is 695 fire pumps. So it's important to know where you're at with what product that you're looking at. I mean, that's just, I think, a general knowledge in navigating the NEC, a codology example that I would describe. I mean, if you're looking at any application, this is the true value of our electrical inspectors and others who are just engaged and have a depth of knowledge of the NEC that far surpasses me, at least, for one, that I can speak to. But to be able to look and say, this is my a light. I'm looking at a luminaire. What article or where in the National Electrical Code do I go that covers luminaires? If I'm looking at an appliance, what article do I go to? If I'm looking at an industrial control panel, you have to ask some conditions. What is it on? Is it on a fire pump 695? Is it on a hazardous application, hazardous location application? It is a Chapter 5, and that could be a UL 1203 or a UL 698. So understand what you're dealing with regards to the application. Fire alarm. So assemblies of electrical control units or equipment containing electrical control units for fire protective signaling systems. That's a UL 864 standard. Freestanding assembly of overcurrent devices and buses for control of electric light and power circuits. UL 891. That's for switchboards. 924, you're going to go for lighting panels, emergency lighting and power equipment. You're going to go to 1563, UL 1563 for control equipment for use with swimming pools, spas. So that's a UL 1563 piece of equipment. So UL 508A isn't your go-to for everything that's controlling. 1563 is swimming pools. Portable control panels containing switches, overcurrent, and cord connected via attachment plugs and receptacles for use at carnivals, circuses, fairs, exhibition halls, motion picture and television studios. That is UL 1640, the standard for portable power distribution equipment. Another equipment for control of fuel cells, photovoltaic systems. That's a UL 1741. I mean, everything. If it's PV related, interconnected systems related, 1741 is like, it's like the black hole. Everything goes to 1741. Yummy Fudge says, similar to scope, are there definitions that are unique to each of the sections? Yes. We're going to get into the definitions of what an industrial control panel is here in a second. Pedestals containing terminals for connection of power circuit conductors, UL 1773. So if you look at the scope of UL 508A, you'll find the narrowing of where Article 409 applies. And you'll understand better when you get outside of an Article 409 application. Okay, so Yummy Fudge was a good... he's a good straight person here. We are going to take a look at what is the definition of an industrial control panel. And I was with somebody over the code cycle, over the second draft meetings. Gotta love this. So we're sitting there talking about the structures and the structure changes within the NEC and all this other jazz. Putting all the defined terms in Article 100. What this individual said, and he articulated it so well, because I was like, man, that is just so true. He made the statement, he says, I thought putting all of those defined terms in Article 100 was a really good idea until I went into NFPA link and had to scroll down through or even open up the book, and you have so many defined terms and in one area. It's almost like it would be so cool if somehow things were divided. And I made this statement. I said, what might be a great idea is to take all of those defined terms in Article 100 and create .2s in all of the different articles and put the defined terms that only apply to those articles in those articles. We all got a chuckle out of that one. But in any case, that was funny though. I mean, you gotta admit, you gotta sometimes laugh at yourself. You know what I'm saying? I mean, we made a move. We moved all the defined terms into Article 100, and some people still think it's a great idea. Some people thought it was a great idea, but get frustrated every now and then. But no matter what, if it was scattered throughout the code or all in one location, you got the same problem. So anyway, okay, industrial control panel. Let's take a look. An assembly of two or more components. There's the two or more components again. All right, so an individual, get your copy of NFPA link out. Hopefully everybody out there is a member, has a membership to NFPA link. Absolutely vital asset if you are doing anything with regard to NFPA codes and standards. Industrial control panel, an assembly of two or more components consisting of one of the following. So it has to have one of the following. Power circuit components only, such as a motor controller, overload relay, fuse disconnect switches, and circuit breakers. So power components only. So you can have you have to have at least two motor controllers, not just one. Overload relays, fuse disconnects. At least two or more components with one of the following. Control circuit components only, such as push buttons, pilot lights. So if I have an assembly that has 6 or 7 buttons on it, right? And maybe some lights that give me indication. I press a button, it tells me something turned on or off. That could be a 508A application. But as we noticed, if it's used in hazardous locations, it's not a 508A. If it's used on a fire pump, it's not a 508A. You got to go to fire pump standards. All right? All right. 3 is a combination of power and control circuit components. A combination of power and control circuit components. These components, with associated wiring and terminals, are mounted on or contained within an enclosure or mounted on a subpanel. And the informational note is what we just said earlier. The controlled equipment is not included. So Yummy Fudge says, I like it all in one place, unless it's being a unique term that only applies to a specific section or article. Yummy Fudge, that is exactly where we were before. I mean, that's the funny part of this is sometimes we make a move and we go, oh my gosh, it's the greatest thing since apple pie. And then we go, man, you know, somebody will come up with, years from now, when guys like me and you are gone, someone somewhere is going to go, I got a great idea. Let's move all the defined terms. Let's keep all of the terms that apply generally in one article. And then let's move all of those terms that only apply to specific articles in those articles. Yes. CMP 11. So here's some of the issues that I have with this defined term. Combination of power control circuit components. It says the industrial control panel does not include the controlled equipment. But when we looked at the standard, when I looked at the, I gotta close. I got too much stuff open. When I looked at the standard, it said, industrial control does not include an evaluation of the controlled equipment. Yeah, so here's what it says in 1.4. Let me do this. 1.4 says this. Oh man, I'll tell you what, you're going to love this. I'm telling you what, format background, I'm going to make it black. And I'm going to do that. Here is, you make it larger. Meanwhile, Tommy's getting larger. All right. Okay. Mounted. Make this a little bit bigger so it's very clear. Okay. Here we go. Again on our own. All right, so here's what 1.4 says. An industrial control panel does not include an evaluation of the controlled equipment, such as motors, heaters, lighting, and other loads connected to power circuits, unless specifically noted on the wiring diagram of the industrial control panel. An industrial control panel does not include equipment mounted remotely from the panel and connected via a wiring system or equipment field installed on or within the industrial control panel. I guess that's different. I guess that still meets that informational note. I was going to sit there and say, wait a second. You know, I could include the load per the standard, but that's not what that second sentence says. I am honing in on this sentence right here. Whoa, landing on my face. Hold on. Let's do gray. I was focusing in on this, unless specifically noted on the wiring diagram of the industrial control panel. An industrial control panel does not include equipment mounted remotely from the panel and connected via a wiring system or equipment field installed on or within the industrial control panel. So that is That's not the load. You're still not controlling the load. So an industrial control panel does not evaluate the controlled equipment, like motors, heaters, lighting, and other loads that are connected to those control circuits. So those are out of the pick. So I thought that second sentence, but and what they should do is they probably shouldn't include that. That should be a separate line item. It should be like 1.5. This is the way if I would make a comment to the standard, I would make this a separate. I would make that a separate 1.5, unless specifically noted on the diagram of the industrial control panel. An industrial control panel does not include equipment mounted remotely. These are two independent thoughts from each other. When I first read it, I read it wrong. So, and that has happened before, and it will happen again. So, dear God, CMP 11, yes, please. All right, so, but what's interesting is you have to have two or more components, and one of those two components has to be power circuit components only, such as motor controllers, overload relays, fuse disconnects, and circuit breakers. Two, now it says circuit breakers. It doesn't say whether it's a classified circuit breaker, or it doesn't say if it is a, oh my goodness, what's the supplemental overcurrent protective device. So supplemental devices would still be a circuit breaker, and it says fuse disconnect switches. It doesn't say if it's supplemental or not. So if you have any type of overcurrent protection in there, one of the following. So if you don't have any fuse disconnect switches, if you don't have circuit breakers, relays, or anything like that, the second list item, again, you have to have at least one of these control circuit components, such as push buttons, pilot lights, selector switches. And 3 is a combination of power and control circuit components. So if I have 3 or 4 power distribution blocks, that's not a 508A assembly, because it has 2 or more, but it doesn't include any overload relays, fusible switches, or circuit breakers. It doesn't include push buttons, pilot lights, selector switches, timer switches, or control relays. And it doesn't have a combination of power and control components. So a enclosure that has 7 or 8 power distribution blocks is not a UL 508A type of application. So that is the industrial control panel. And I think that's the major one that I would. Hey, yeah, don't forget those thumbs up. Give me that thumbs up. Give me the thumbs up. Don't forget to subscribe, too. I mean, this is IAEI we're talking about here. So let's just do an overview of 409. 409 has a part 1, a part 2, and a part 3. Part 1 is always going to be general. So part 1 is general. Part 2 is installation, and part 3 is construction specifications. So what's in part 1, we already talked about the scope. We know that in 409.3 other articles, well, we don't know that. Ooh, I've got to log in. It made me log out. That's not good. So in 409.3, all it says is, in addition to the requirements of this article, industrial control panels that contain branch circuits for specific loads or components, or are for control of specific types of equipment addressed in other articles of the code, shall be constructed and installed in accordance with applicable requirements from those articles. So that's just a catch. I mean, do you need 409.3 to know that if I have an industrial control panel that's used, say, in an elevator, that I've got to follow the rules for elevator installations? I don't think so. But I'll have to wait till you're done to see if you get a thumbs up. Oh, thumbs up early and often. That's my opinion, right? All right. Froming in the house. Okay, so in part 2 is where we get to the meat and potatoes. Now, part 2 has the minimum size and ampacity for the conductors, and we're going to take a look at it to understand, is that the conductors that are feeding the industrial control panel, or are that the conductors that are inside the industrial control panels? Time will tell. 409.21 is our overcurrent protection. 409.22 is our short circuit current rating, and 409.30 is the disconnecting means. 409.60 is bonding, and then finally in 409.70 is our surge protection. So let's take a look at 409.20. It says the size of the industrial control panel supply, so it is the supply conductor, shall have an ampacity not less than 125% of the full load current rating of all heating loads, plus 125% of the full load current rating of the highest rated motor, plus the sum of the full load current ratings of all other connected motors and apparatus based on their duty cycle that may be in operation at the same time. Wow. I mean, look at this. I mean, help me. So let's go back to that push button. If I have an industrial control panel that has nothing but buttons, just think about that one. The size of the industrial control panel supply conductor has to have an ampacity not less than 125% of the full load current rating of all heating loads. Well, if they're all push buttons, that wouldn't apply. Plus 125% of the full load current rating of the highest rated motor. Well, there's no motor because it's just a push button. Plus the sum of the full load current ratings of all other connected motors and apparatus. What's an apparatus? What's an apparatus? So we're going to go to NFPA link. I'm going to open another instance. It's another nice thing about NFPA link. And I'm going to do a Control-C so I get the exact words. I'm in 70. I do a search. I look for Control-V apparatus. Is it a defined term? Oh. All other connected motors and apparatus. Well, there's a defined term, associated apparatus. Apparatus in which the circuits are not necessarily intrinsically safe themselves, but such apparatus is one of the following. Electrical apparatus. What is an apparatus? Yummy fudge. Yeah, they should have just said 125% of all the stuff that's in there. My goodness, what the heck? Let's go to Merriam-Webster. Webster definition of apparatus. And now, if you have two apparatuses, are they apparati? All right, so apparatus is a noun, a set of materials or equipment designed for particular use. A group of anatomical or parts functioning together, the functional process, the machinery of government. Oh, there's problems. A group of, I would say, a set of materials or equipment designed for a particular use. So that's pretty generic. If I look at the requirement, and apparatus based on their duty cycle that may be in operation at the same time. Yummy fudge, I agree with you. 125% of what's in the freaking box. But it says plus. So it says have an ampacity not less than 125% of the full load current rating of all heating loads, plus 125% of the full load current rating of the highest rated motor, plus the sum of the full load currents ratings of all other connected. Oh, it doesn't have the 125%. the sum of the full load current ratings of all other connected motors and apparatus. So if I'm just lights and push buttons, depending upon what the push button is controlling, if the push button is just like, say, a shunt type of a deal to turn a starter on and off, but it's not carrying that load, then the feeder or the branch circuit that supplies that, the circuit that supplies that, would just be full load current ratings of all other connected motors and apparatus. So, wow. 409.20 looks to contradict the definition in that it addresses loads attached to an industrial control panel. Well, this is the installation. This is the circuit that is supplying the industrial control panel, not between the industrial control panel and the load. This is the supply conductor. The problem I'm having is full load current rating of apparatus. I don't have a full load current rating of, say, push buttons. If I have a bank of push buttons, which would meet the definition of an industrial control panel, I don't have a full load current rating. I just have a light, an LED light or whatever. And then I have, if it's like a shunt, if those push buttons are, if I'm not feeding the circuit through that, if I'm just providing a dry contact, oh man, minimum size and ampacity. The size of the industrial control panel supply conductor shall have an ampacity not less than, and they give you the math, 125% of the full load current rating of heating loads, 125% of the full load current rating of the highest rated motor, and then you add up the rest at their ratings, period. 409.20, I think, can use some love. What do you think, Fred? Yummy Fudge? How about you, Mr. Froming, who's going to give me that thumbs up here in a minute? Okay, let's talk overcurrent protection. 409.21, industrial control panels. Industrial control panels have to be provided with overcurrent protection. And that's, I mean, it'd be no different than providing overcurrent protection, etc. The overcurrent protective device that's located, the protection shall be provided for each incoming supply circuit by either of the following: an overcurrent protective device located ahead of the industrial control panel, a single main overcurrent protective device located within the industrial control panel. All right. And then, so where overcurrent protection is provided as part of the industrial control panel, the supply conductors have to be considered as either feeders or taps as covered by 240.21. That's why they call it, that's why they say the incoming supply circuit. You can't say the incoming branch circuit, because it could still be a feeder tap. It could be a feeder, all that jazz. So, or it could be truly a branch circuit. The rating or setting of the overcurrent device for the circuit supplying the industrial control panel shall not be greater than the sum of the largest rating or setting of the branch circuit, short circuit, and ground fault protective device provided with the industrial control panel. Shall not be greater. Plus 125% of the full load current rating of all resistance heating. So that, again, I think the 125% is dealing with the continuous loads. If they would just say, treat this as a continuous load, that is all we need. I think throwing in the percentages here is confusing. Could be confusing. Then you get the short circuit current rating. Now it gets kind of complicated with short circuit current ratings. Short circuit current ratings are very important for a few different reasons. I think I can. Yes. So here is a here's an example. I'm going to show you a video of what happens when you exceed the short circuit current rating of a piece of equipment. Let's see if we can make this happen. Hold on. Hold on. Movie. I have that unmuted. Oh, I know what I gotta do. I gotta get rid of the echo.
3, 2, 1, 0. Uh-oh.
So that is an example. That's an example of exceeding the short circuit current rating of a piece of equipment. The fault wasn't inside the equipment. The fault was outside the equipment, and the components that are inside can't hold it together under the stresses that are presented or placed upon the equipment because of the available fault current. All right. So let's do this. Let's talk about that for a second. Let's talk about, where's my waveform? I should have a waveform. Close this file. Close that file. Don't save that file. Where is my, here we go. I think this is it. So a short circuit current rating now. A short circuit current rating of an industrial control panel is not a simple thing. There is a lot to be considered when you're dealing with short circuit current ratings. Here's an example of what I'm talking about. A short circuit current rating of an assembly is not the ability of the assembly to stop the flow of current. It is trying to, hold on. It is, oh man, give me a second here. Why can't I end show? Jeez, oh man. All right. There we go. All right. So I'm going to hit, you know what I'm going to do is I'm going to just drag this over. It's a lot easier. I'm going to move this way, and I'm going to move this down. All right. So the ability of a component to let current pass through it and not stop its flow is what a short circuit current rating is. Circuit breakers and fuses and things of that nature have interrupting ratings, but equipment like an industrial control panel has a short circuit current rating. So here is this is a waveform that your control panel would see if you did not stop the flow of current. If you didn't have a circuit breaker or a fuse ahead of it, what's in blue would be seen by the piece of equipment. That first half cycle, this first half cycle right here, from that point to this point, that first hump, that peak value, and the slope of that leading edge, what I mean by the slope, it's the rate of rise. You went from a nice waveform that was symmetrical and I'd say you went from a flat roof to a peaked roof, right? So your waveform went from something like this to something like that. So that first half cycle, that rate of rise, the amount of current change for a small amount of time is what imposes the magnetic forces on the equipment, the conductors, the terminations, the industrial control panel, panel board, whatever it is. All of that force is because of that rate of rise change. The heat that's generated comes from that, but for the most part, the heat is coming from the duration that you let the current flow. So the goal, what our desire is to knock this peak down to something that is much less for a very short period of time. We don't want to let that first half cycle, we don't want the equipment to actually see the full brunt of that fault current. A good example of that is found in, I'm going to escape out of that, and I'm going to close that. I want to bring up another video. Nope. Media not found. All right, so videos. There we go. Videos. And excuse me. Jeez, oh man. SCCR, I think I'll search. There we go. So the cable whip. All right, I'm going to show this other video. Now, this video here has about 24 or so thousand amps flowing through a 2-aught conductor for one cycle. One cycle only. All right. So let's take a look at that. All right, so what that showed us was the force that is placed on a conductor with just one cycle of fault current. Now, we took the exact same demonstration and we put a current limiting fuse in front of that. So now I've got that 24,000 amps, but I've got a current limiting fuse that is going to reduce the peak value and the amount of time. You're not going to see a full cycle. You're going to see less than a half cycle and probably around quarter of a cycle. Remember, one cycle is 1 over 60, 0.016 seconds. A half cycle is 0.008. A quarter cycle is 0.004 seconds. This video is going to show you an example of that same video that we showed you, same circuit, but with a current limiting fuse at the beginning of the circuit. You're going to have to watch very closely at the front of the conductor. And that was it. So that was a non-event. Why? Because we took that first half cycle and we knocked it down to something very low from a peak perspective for a very short period of time. Removed the magnetic forces and the heat. Now, I'm sure when you look at that or held that fuse would be kind of warm, if not hot, because of the fault current that it interrupted. But it took the brunt of the fault current, providing a lot of removing all of the pressures and all of the forces on the power distribution system itself. And you know what I have not been doing is watching. Here we go. Freddie B. Well, one motor is at 125%, and any additional motors are only at 100% in addition to the heating loads. Yes. Yummy Fudge. Best explanation I've heard about what the short circuit training is for, etc. Thank you. You're welcome, Yummy Fudge. Thank you. Breakers have a rating, say the 10, 22, or 65K, and these should be rated to at least maximum fault current. Yes. So let's talk interrupting ratings for a second. A circuit breaker has an interrupting rating. So if you think of any of these, any circuit breaker or fuse, in fact, let me just do this. I'm just going to grab. I do have a TD. Oh my. You know what I need to do is I clicked on the wrong file. All right, here we go. I was going to say I need to organize my files better. Interrupting ratings. So let's talk about there are different types of circuit breakers. You have multi-case, etc. This is the waveform that we were just talking about from an interruption perspective, about hitting and bringing down that peak down to a lower value, removes the stresses. There's your whole case of molded case circuit breakers, always up to 2,500 amps, and look at the interrupting ratings, interrupting capabilities, 10,000 amps to 100,000 amps. Now, what happens? How does a circuit breaker do what we say it's going to do? We have a complete mechanism in here, but the important parts to think about, here is your arc extinguisher, right? So you have your arc extinguishers. You have the contacts. This separates, and you'll have an arc being drawn between these contacts, and the extinguisher, the arc extinguishers, basically divide and conquer that up. So all of this mechanism has to hold it together while it's clearing the fault. The contacts are, they have contact assemblies, and what they'll do, this is what pretty much everybody's doing on the market right now, is they have this loop back method that basically helps it become a current limiting type device. And because of the way that loops back, because of those magnetic forces propelling each other apart, that helps pull those terminations apart. The arc extinguisher itself is, as those contacts are separating, those plates are cooling the arc and stopping the flow of current through the circuit. Now, when you think about the trip curve, okay, this portion is a bimetal. So this bimetal bends, basically. It starts to bend, and then the latch drops after that bimetal bends enough. This portion, which is the instantaneous, I call this the we always depict it as a plunger and a coil and a plunger, but that's not necessarily the case. And quite often in these applications, what that ends up being is I call it the clapper. You have two pieces of metal that are like this, and current's passing through this one, and the latch is over here. You're either bending the entire structure and dropping the latch, or you're pulling in one portion of it because of the magnetic forces due to the high fault currents. You pull that in and it drops the latch. So the plunger, the magnetic element with the plunger is a great example, and they do that on some, I know in some European designs from an international perspective. But in your typical thermal mag breakers that you and I know and love, we don't utilize those. That adds a lot of cost to the circuit breaker itself. It does present a very nice trip curve, but I doubt you'd pay for it. But in some cases, we do have that from a application perspective or from a design perspective. Whoa, sorry about that. All right, so the interrupting rating is the ability of the overcurrent device, whether it be a circuit breaker or fuse, to stop the flow of current, and it has to do it safely. 110.9 is your reference for that. 110.10 is your short circuit current rating reference. 110.9 is your interrupting rating requirements. And I highly doubt these are going to work. Oh yeah. So that is a fuse that has exceeded its interrupting rating. And a typical it's a class H fuse.
This is a serious misapplication.
The class H fuse has a 10,000 amp interrupting rating, and we hit it with 50,000 amps. And it achieves an unintended rapid disassembly in the field. This is the circuit breaker. Whoop. Again, it's a misapplication of the product. The interrupting rating here is 14,000 amps, and the available fault current that this tried to interrupt was 50,000 amps. And again,
this is a serious misapplication.
So it's really critical to understand that the rating of the overcurrent protective device has to be greater than the available fault current. If those were inside of an industrial control panel, you would have a unintended rapid disassembly of that industrial control panel. So, how do I determine the short circuit current rating of an industrial control panel? Good question. We get load centers. Oh boy. Thanks for including the videos. Very educational. Sure thing, Laurel. Thank you. It's always a cool video. Absolutely. So, Patrick, is it correct that a 508A industrial control panel cannot be used as a service panel, not fed by service entrance conductors, even if the said panel contains a QO load center. It's a square D type of load center with a main breaker and adequate SCCR. That's a good question. I'm going to search the standard, the UL 508A standard for service. Oh boy. These requirements also cover industrial control panel enclosures and industrial control panels primarily intended for flame safety supervision of combustible fuel type equipment, crane or hoist control, service equipment use. So it does say service equipment. So I would argue surge protective device designations, type 1. That's okay. Hold on. That's surge. The cord shall be hard service or junior hard service flexible cords. Control circuits of power operable service disconnecting means. Okay, here we go. Well, you know what, Fred? Is it Fred or Patrick? Nope, Patrick. This is out of the standard 508A. Patrick, it says, these requirements cover industrial control panels for service equipment use. These requirements also apply to other special use industrial control panels that are intended for use as service equipment. So yes, I could have a industrial control panel and it could be listed as service equipment. So I think, and hopefully that answers your question. That's right out of the standard. So hopefully that answers your question. All right, so let's keep going. Fred B, we get load centers listed for 10,000 amps. Well, the load center is 10,000 short circuit current rating, not an AIC rating. I know what you mean, but because we're trying to, Fred, because I want to just stay true to the defined terms. A load center panel board. Load center is not a load center and a panel board are one and the same, just for everybody's clarity. And a panel board or load center cannot have an AIC rating, which is an ampere interrupting current, because a load center doesn't interrupt current. The panel board itself will have a short circuit current rating. Now, it just so happens that a panel board or a load center will have a short circuit current rating based upon the lowest interrupting rating overcurrent device that's installed on the panel board. Make sense? So from a panel board's perspective, you have a 10,000 amp short circuit current rating. And the main is listed for that as well, and all breakers installed should also be listed to that minimum. Yes, because remember, the way a panel board I'm going to look in my images, pictures, and I'm going to type in label. Typing in label. Here we go. Oh, good example. Man, I tell you what, I didn't think I was going to find it this quick. All right. When used as surface equipment, this device accepts color hammer. That's the torque. Wrong label, right? Eaton load center label. Here we go. I'm looking at a panel board or a load center rating. Okay, so this tells me it's a 200 amp max. And then we look over here. There's your series connected short circuit current ratings. and it tells you for a series rated system, that circuit breakers in this group are not required in series ratings. So main panel feeds. So here's your system AIC rating, series connected short circuit current rating, branch circuit breaker, and there's your panel, and there's your main overcurrent device. Where is it at? Type ground wires, applications, torque, panels with this, use color hammer type breakers, some rating stabs 200, all copper plated, all that good stuff. Additional breakers shall be of the same manufacturer and type and shall have an interrupting rating equal to or greater than the interrupting rating of any circuit breaker installed. Breaker handles, surface flush, installation use of the equipment terminals. So to determine the short circuit current rating of this panel board, you need to know the minimum interrupting rating of any of the circuit breakers that are installed. Okay? Let's close this one. I'm going to go back to Eaton Load Center labels. I'm looking for the labels. Give me a second here. I had some really good labels. Breaker ratings, arc flash. And you'll have the interrupting ratings labeled on each of the circuit breakers. And I had a... Here we go. This is a power line C. Okay. So this is this is a 480 volt, 3-phase. This section is rated for use on not more than 65,000 amps of kiloamps of amperes at 480 volts. When protected by a current limiting main device, not more than 800 amps. The short circuit current rating of this switchboard, see, it's a recipe. So this is a switchboard. This is a really good example. The short circuit current rating of this switchboard section is equal to the lowest rating of 1, any section electrically connected in series, or 2, any installed panel board having a marked short circuit current rating, or 3, any device installed except as noted in the series rating information manual. 4, 42,000 amp max for any lineup containing an RDC feeder device mounted on the distribution chassis. So we give you the recipe to determine the short circuit current rating of that equipment based upon what's installed in the equipment. So short circuit current ratings of panel boards and switchboards and industrial control panels are dependent upon the makeup of what's inside. All right? And it's a very complicated topic, and maybe what we'll do for the next discussion is get into how you determine the short circuit current rating. And maybe I'll try to get a guest to help convey that. Fred says, I've seen one panel that had shown on label 3 different SCCRs that was based on the main breaker AIC. Does that mean the bus and components inside could be up to a maximum of the highest? So here's the thing, Fred. If, for example, let's say you have a circuit breaker as the main in a panel board. All right. Just pulling that out, which I probably should not have done, but I did it. All right. So let's say that you had oh boy. So let's say that you had panel board that had circuit breakers like this, okay? And let's say this was, I don't know, a 800 amp, and it was 65 kiloamp interrupting current. And let's say that these were 10,000 amp interrupting. The assembly would have a 10K SCCR because of the weakest link. Now, if you had what we call a series ratings, if you have a series rated system and you had a main breaker, and let's say you had the same deal where you had these other breakers, and let's say that this was 65K and this was 10K, and they were series rated for 65K, then your panel has an SCCR of 65K because of the series ratings. But you just can't put any other device inside that panel. Okay? It has to be a specific device type that's a part of that series ratings. So your question was, let me get this right, 3 different SCCRs that was based on the main breaker interrupting current. Does that mean that the bus and components inside could be up to a maximum of the highest? If you're series rated and it says 65,000, then everything is rated 65,000. That assembly is rated 65,000 because your overcurrent devices are going to work together to limit the amount of current and the amount of time it's going to bring that peak down. If you have 3 different short circuit current ratings, I'm not sure where the 3 different come from. It could be that you have the series rated, and you could be that, well, it doesn't matter about the main because it's the weakest link. If if your main was 65K and all of your branch and feeder breakers were 65K except for one branch or feeder, let's say you had one branch breaker that was 10K, the entire short circuit current rating of that panel board is now 10,000 amps because of that one breaker. So Fred says, so I had a panel that had a possible up to 22.5 SCCR, but it said that it was only, yeah. So if all of your breakers in that panel, if you had a main and you had right? So if you had this, and this was 65K, and this is 10K, and this is 22K, then your SCCR is 10K. If you change this out and said, I'm putting a 65K in, then you're at 22K because now that is your weakest link. If you changed that out and said I'm putting 65K, then you're back up to 65K because everything is rated 65K. In your question, you said 22K, then if all of your breakers are 22K, then it's rated for 22K. Or if these are 10K and these are series rated to 65K, then the rating of that equipment is 65K. Make sense? Because a panel board is the short circuit current rating of a panel board, which is not a UL 409, is based upon the components, but it's very similar to a UL 409 industrial control panel. But the difference is that an industrial control panel, you're going to have power distribution blocks, you're going to have other types of overcurrent protective devices, conductors, things of that, maybe push buttons, lights, whatever, in that industrial control panel, and the short circuit current rating is going to be the weakest link. It was based on a pairing of specific breakers, so that is a series rated system, Fred. And you've got to follow, in Article 240, we have a section 24090 something, I think. I think it's 24090 something. I'd have to go back and look at what section that would be. But go back in Article 240 for series ratings and you'll see the rules around series ratings. There are conditions to get that series rating. So industrial control panels don't have to be listed. I can't find anything that says it has to be listed. We talked about the general requirements and we spoke to the installation requirements. Obviously, we didn't talk about the voltage rating. You have to have the right voltage rating. We talked about the conductor sizing. Voltage rating is very important too. I mean, if you have a system that is corner grounded delta or something like that, then you're going to have to pay attention to those details. You got to make sure that you don't exceed the voltage, just like any other type of application, any type of a piece of equipment. So we went over the scope, we went over other articles, we went over Part 2 installation. And installation, we talked about overcurrent, short circuit. Disconnecting means that supply motor loads shall comply with Part 9 of Article 430. It doesn't say that you have to have a disconnecting means for the industrial control panel, which I'm surprised, but that's what it doesn't say that. Bonding shall be grounded and bonded in accordance with 409.60. So grounding, an equipment grounding conductor, size in accordance with 251.22, has to be connected to an equipment grounding bus. And then it has to, multi-section industrial control panels have to be bonded together. And then surge protection, safety circuits for personnel protection that are subject to damage from surge events shall have surge protection installed within or immediately adjacent to the control panel. And then Part 3 is the construction, which really gets into the standard itself. And look, service equipment, 409.108. Where used as service equipment, each industrial control panel shall be of the type that is suitable for use as service equipment. And that was, who asked about that? I believe that was not Fred. Patrick. I think it was Patrick. So, all right. I got to turn off. Thanks for joining in for another IAEI News Live. We went a little bit over our time, about 20 minutes over our time. And hopefully I'm not missing a meeting right now. So in any case, thanks for joining in. Thanks for spending some of your time with me to talk about industrial control panels and other related topics. We got dug a little deep into a few areas. So hopefully you got something out of today's session. Thanks for joining in. Thanks for what you do for the electrical industry and for electrical safety. We will see you next week on IAEI News Live. Take care, everybody. Thanks, Steve.